Hello, I'm Chen. Joining me today are my group members Chen Rui and Han Ming. We are excited to present our SC1015 DSI mini project, where we are tackle the challenge of student dropouts using predictive modeling. We selected a dataset titled Predict Student Dropout and Academic Success from Kaggle. This dataset offers a comprehensive look at the factors that could predict student retention and success in higher education. Before diving into our project, let's see the context. In America, as of July 2021, about 32.9% of undergraduates do not complete their degree, 24.1% of first-year students drop out within 12 months, and the dropout rate of degree seekers have reached 25.7%. Overall, the dropout rate among all undergraduates have hit to 40%. The diagram on the right highlights an increasing trend in dropout rate over the years. This motivate our study. The increasing trend in dropout rate carries significant negative impact. These include reduced earning potential, increased unemployment rate, higher risk of accruing debt without return on investment, economic downturn, social and psychological effect, and a loss of human capital. Each of these factors worsen as dropout rate climb, underscoring the urgency of addressing this issue. Given the severity of these consequences, it is crucial that we do not ignore this problem. Our project aims to develop a predictive model that uses historical data and relevant predictors to accurately identify students at risk of dropping out from an education institution. This dataset contains 4,424 records and there is no missing value. Before we start analyzing, we have to do some preliminary data cleaning. After checking, the dataset has 0 null value, so we don't need to clean any null value. Followed by category encoding, check for correlation and features engineering. As our target variable contains category data in the form of string, we need to perform category encoding. As mentioned before, there are 3 outcomes of student status, which is enroll, dropout, graduate. As we are interested to find out the student at risk of dropping out, in this case, we choose to merge enroll and graduate as one class, 0 from dropout, 1 for enroll or graduate. Categorical encoding is a process used in data pre-processing to convert categorical data into a numerical format that can use to understood and used by machine learning algorithm. Since most machine learning models are designed to work with numerical data, categorical encoding is an essential step when working with datasets that contain non-numerical features, such as name, labels, and other categories. We do a correlation between the various variables against the response. Value close to 0 has little correlation with a response, while value close to -1 or 1 indicates strong correlation. From this, we can see that the top 5 variables that have a strong correlation to the response variable are curriculum unit second sem grade, curriculum unit second sem approved, curriculum unit first sem grade, curriculum unit first sem approved, and tuition fee up to date. Also, we revert dataset that correlation is less than 0.05. Features engineering is a machine learning technique that leverages data to create new variables that are not in the training set. It can produce new features for both supervised and unsupervised learning, with the goal of simplifying and speeding up data transformation while also enhancing model accuracy.
Thank you, Qicheng. After data preparation and cleaning, we step in the part of data exploration. We visualize the top 10 most correlated factors. We then find 5 interesting factors to explore deeper. The first one is about grades with highest correlation value near 0.6. We calculated SEM1 and SEM2 grade interaction and illustrate as shown. Blue represents dropout and orange represents non-dropout, basically enrolled and graduated. We can see the conclusion that students with better grades are not easily going to drop out. Then, we explore similar factors about total approved CU, which more CU is better. For the next session, we explore data about financial conditions. We study debt, scholarship, and tuition fees up to date, and find that with better financial conditions, basically no debt with scholarship and tuition fees up to date, students are less prone to drop out, while those with worse financial conditions are quite prone to drop out, as the blue region takes more percentage. We then explore other factors, including attendance, gender, and age. We find that absence affects dropout rate, and male students surprisingly have a 50% dropout rate. We finally look through on age, and most enrolled students are from 18 to 2012. We then draw the box plot and find the dropout class has a higher average age. In conclusion, our data-driven insights includes grade, CU, financial conditions, attendance, gender, and age as shown above. And universities should highlight these particular factors to intervene and offer specific help. We will then move on to advanced models to predict targeted students' dropout possibilities to trace them.
As we are tackling a classification problem, dropout or no dropout, we use machine learning models that are able to predict classes. These models that we use are decision tree, random forest, logistic regression, k-nearest neighbor, and naive Bayes. Before we move on, I would like to talk about these following terms: precision, recall, advanced score, and accuracy. Accuracy is a measure of overall correctness of model. Precision is the access in the model accuracy in predicting positive label. Recall is to reflect the model's ability to identify all relevant class. And F1 is the balance precision and recall for cases where false negative and false positive are crucial. All the formula is provided in the slide as well. Initially, we used the decision tree model which was taught to us during labs. And this gives us pretty good models with an overall accuracy of 87% and a F1 score of 0.78. Next, we move on to random forest model. Here we get a slightly better accuracy for 88% with also a higher F1 score of 0.79 for predicting a dropout class. Then we have logistic regression model, sitting at also 88% accuracy with an F1 score of 0.78 for predicting dropout rate. Moving on to k-nearest neighbor models. We have an accuracy of 85% and a F1 score of 0.71 for predicting dropout class. Last but not least, naive Bayes classification model with the lowest accuracy of 83% and an F1 score of 0.72. Overall, looking at the performance of each different models, our team has decided that the random forest model is the best performing model for our dataset. Even though most of the accuracy of the different models differ from plus or minus 0.03 from 0.85, which is only 2 to 3%, we're primarily interested in predicting correctly for students who are at the risk of dropout. And with the precision score of 0.86, the random forest models will most likely predict correctly for us. Even though its recall is less than the recall for decision tree model, overall this model performs better than the decision tree models, which is reflected from its 0.79 F1 score as compared to the decision tree 0.78 F1 score. This project has a profound learning experience for us, extending well beyond the classroom boundaries. Firstly, we deepen our understanding of decision trees, a model introduced in our coursework. Additionally, we also explored and apply more complex models like random forest, logistic regression, and more, which we learned through extensive online research. Secondly, we dive into cross-validation techniques, which are crucial for model validation, mitigating overfitting, selecting the right models, turning parameters, and ensuring reliable performance estimation. Lastly, we tackle features engineering, which enhance our model's accuracy, simplify the models, manage non-linear relationship, reduce overfitting, and increase overall robustness. Based on our finding, we strongly recommend that the university enhance support mechanism for students. Financial aid can increase access to education, academic support, and boost performance and offer personalized learning opportunity. And counseling and advising can crucially support students at risk of dropping out. These interventions are not just beneficial, they are necessary to address the dropout risk identified by our predictive models, particularly focusing on improving grades, which is the key factor in retention. Lastly, we want to thank our teaching assistant, Liu Yanwei, and our course coordinators.